Welcome to October 15th LeetCode Challenge. Separate black and white balls. There are n balls on a table and each ball has a color, black or white. You are given a zeroed index binary string S of length n, where 1 and 0 represent black and white balls respectively. In each step, you can choose two adjacent balls to swap them. Return the minimum number of steps to group all the black balls to the right and all the white balls to the left. So we're given S, which is a binary string containing zeros and 1 being black and white respectively. So we have black, white, black. And we basically want to be able to see how many the minimum number of steps we could do to group all the blacks to the left and all the whites to the left. Wait, all the black balls to the right and all the white balls to the left. So given white, black, black, white, black, we could group all the black balls to the right in the following way. So basically swap index 0 with index 1, and we get 0, 1, 1, or we get a white ball and black, black. Initially, the ones not all grouped together, requiring at least one step to group them to the right, which makes sense. So say we have 1, 0, 0. So basically what we need to do for this one is swap index 0 and index 1, so we get 0, 1, 0, and swap index 1 with index 2, we get 0, 0, 1. So this would be the most minimum number of steps we could take. It can be proven that the minimum number of steps needed is 2. Essentially we need to swap it twice. No matter which one you swap, the minimum will be 2. So say for this one we got an array of 4 and we get 0, 1, 1, 1. So basically all the black balls are already grouped together to the right, so therefore we don't need to make any more swaps, so therefore output is 0. Our constraints are that n is equal to the size of the length of the string s, and that's between 1 to 10 to the 5, and each index of the string s is either a 0 or a 1. Note that these are characters. Alright, so basically when we find a white ball in the array, we need to move it in front by swapping it past the black balls. That's one way of approaching it. So let's develop a counter to be able to push all the white balls to the front, and we need to find a way to swap it with each black ball in the front. So each swap moves the white ball to the white ball forward by 1 position, and the number of swaps for each of the white balls equal to the number of black balls before it. So essentially we build a counter where we swap each of the white balls with the black ball until we have basically all the black balls on the right and all the white balls on the left, and the count will give us the number of minimum swaps we can make. As we go through the array, we need to develop 2 variables that will keep track of the white balls and the black balls we've passed, and we need to find the times the number of white balls we add to the basically the swaps we do as well. So when we're done, we'll take the number of total swaps to have the answers. So in order to solve this using a counter approach, let's initialize initialize variables. The first one we're going to initialize is called total swaps, and we'll call that a long total swaps equal to 0. And next we want to initialize. So basically total swap is going to keep track of the number of total swaps required. And next we're going to count, basically to initialize a variable 0 to count the number of black balls you've encountered when swapping with a white ball. So it will be black ball count, and that will be initialized to 0, and this will be an int. Alright, next thing we do is loop over each character in the string s, and let's iterate through. I'll just write some notes here. Iterate through each ball in the string. So to do that, we'll do a for loop for int I equal to 0. What we want to do is increment when I is less than strength string s dot length, and then we want to increment I afterwards by 1. And so when you iterate loop through each character in the string s, if the character is 0, then we add the current of the black ball count to total swaps. So if character at the index I is equal to the character 0, then we want to swap with all black balls to its left. And to do that, we do total swaps incremented by the long typecasts of black ball, because black ball currently is an int count. And we do that. Else, what we want to do is, if it's not a basically a 0, meaning it's a black ball, then it's got to be a white ball. Then if it's a white ball, then what we want to do is increment our count, or black ball count. Increment the count. Black ball count plus plus. So by doing this, we have the total number of swaps, and once we do those two conditions, we exit the for loop. That means we iterate through each character in the length of s. By the end of this, we should have the number of total swaps being our minimum number of steps to be able to group all the black balls and the white balls together. So let's take this for a run. Seems okay. Excellent. So what we have here is that the algorithm traverses through the input strength s only once. So through this for loops here, taking a linear time, and the operations inside it as well also take constant time. So the overall time complexity is big O of n for this for loop right here. Space complexity, the algorithm uses only two variables, total swaps and black ball count, which are constants. So therefore, the linear time complexity is constant, big O of constant time, space. All right, that's it. Have a great day, everyone.